Hello, everyone. One thing I was wondering that usually there are a lot of students who ask for the what is the meaning of the Kaplan-Meier survival plot, how you can explain it, what does that mean, different colors, and what is blue, what is red, what is x-axis, what is y-axis. So I will explain these things. Also, what is hazard ratio and so on and so forth. So we will dive into it one by one so that you can have a good understanding about the Kaplan-Meier curve. Basically, a Kaplan-Meier curve or Kaplan-Meier survival curve, it shows how a group of patients survive over time. The x-axis represents time. Here you can see that this x-axis is showing that months, and 0 to 20, 40, 60. That this is actually uh, the time. And the y-axis, on the other hand, the y-axis is that the probability of survival, that how much the patient is survived, how many patients, how much percent of patients are survived, or probability of the survival is shown by the y-axis. Each step downward in the curve actually represents a patient event, typically a death or relapse. So there are two ones, as I showed in the previous example in the previous video, that one is the a death or alive, one is the disease free or reoccurrence. So here I'm saying relapse. So there are two groups, one is death and one is relapse. There is it's not shown here actually, but you may see in some no, it's here. Yeah, you can see that these are these uh, uh, bars on the survival curves, like red and blue. You can see that there is one vertical small lines. These are actually the censored events. And what this censored event mean is that when the patients are censored, it's, for example, it's we have lost the follow-up of this, and that is shown by the small vertical tick or mark on the curve, right? And also there's a way to explain the expression, some survival plots. This is from the GPA, as I'm using GPA these days to explain gene expression analysis. Here, blue is for the low expression, which is mentioned here, and high is for the red is for the high expression, and that is divided by median. And also, uh, there is another thing you can see, that there is a hazard ratio that is mentioned here, hr. Hr is actually the hazard ratio, and hazard ratio is the basically the it quantifies the risk of an event happening in one group compared to the other. Like there are two groups, one is high and one is low, so it actually gives you the risk of the event, like how much is the risk of being death, or how much is the risk of being uh, of getting a relapse. So if the HR is greater than equal to is equal to 1, then it is that there is no difference between the groups. But if HR goes above 1, it means that there is a higher risk in the high expression group. Or if HR goes down, it means that there's lower risk in the high expression groups. So I think these couple of things are now. So for example, if this is the um, if it is showing that there is a 1.4 hr, so it means that there's a 1.4 chance of 1.4 times higher chance of having a risk in the high expression group compared to the low expression group. And the last thing in the Kaplan-Meier survival curve is the confidence interval. That confidence interval is not mentioned here in the output of the GPA, but it's you can see that there is a it has shown that I have included confidence interval in the GPA has included confidence interval in this plot. And what basically confidence interval mean is that the 95% confidence interval actually tells us that the range in which the true HR likely falls. Like if the HR is true, and if the confidence interval does not include 1, the result is then statistically significant. But if the confidence interval uh, does not is include 1, then that is not significant. For example, if there is a range of confidence interval from 1.4 to 2.9, then it means it is significant. But if the confidence interval range is less than 1, like zero point 0.9 to 1.7, then it is not significant. So I think these are few things. One is the HR ratio, one is the p value, one is the y-axis, x-axis, confidence interval, and what is high expression, what is low expression. So basically, this whole process tells us that if the gene has any potential in the association with survival, and then this type of analysis help us to identify potential biomarkers and understand the gene function in the disease or any cancer what we are looking into cancer prognosis. For example, here we are looking into liver cancer, right? So I think it's enough. And if you found this helpful, don't forget to like and subscribe and comment below if you have any questions or want me to explain more bioinformatics tools. See you in the next video. Thanks a lot.